Case Study: Connecting to Many Remote Locations.
In 2004, the City of Montreal embarked on a 20-year, $10 billion project to upgrade the quality of drinking water production and distribution in the city. This initiative includes better metering, infrastructure repair, new purification systems, and plant upgrades. The goal is to improve efficiency throughout the entire system. Water resource engineers at the head office were recently given the job of integrating the production data from all of the city's 7 pumping stations. Their task was to provide a reliable and secure way to bring key data from those satellite plants into a central location for storage and analysis. The data is available through an OPC server at each location, but networking OPC using DCOM is neither reliable nor secure. So the engineering team decided to use tunneling. They tested several popular tunneling products, but the only one that worked well was the DataHub. They needed to collect data from all the remote stations in a highly secure way and log it at their central location. Neither the central client nor anyone else should be able to write back to the OPC servers. They also needed to send the collected data to a database at the central office and bridge to other OPC servers there. In addition, each pumping station needed to receive some of the data collected from the other pumping stations. And finally, some of the pumping stations were running fully redundant SCADA systems, so they needed redundancy built into the system at those locations. Let me explain the details of their configuration. On the Data Hub at the central office, they created a read-only tunnel to receive the data from each location. Now that the central office has all the data, it can log to the database and bridge it to the OPC server. Then, at each station, they created a read-only tunnel to the central data hub to get the data from each of the other stations. This gave the operators at each plant a complete picture of what was going on throughout the system. With data logging and secure tunneling in place, the next feature to implement was redundancy. The team was able to establish a connection to the redundant OPC servers such that if one server failed for any reason, the OPC Data Hub would start receiving data from the second OPC server. Having all the data at the remote pump stations has allowed engineers to make better decisions since they know what is happening across the entire city. They were able to use the OPC DA, tunneling, data logging, bridging, and redundancy in DataHub to securely network redundant OPC servers, log to a database, and bridge to a central OPC server.
If you would like to learn how to implement tunneling with DataHub, click the link below.